In this video, I will be going over the Test 2 study guide questions on the calculator permitted portion of the review. So the first one here, we're going to find the product of these binomials that are multiplied together. So here we're going to take our first term, 6x, and we're going to distribute to the 4x plus 5. And then we need the negative 7 also distributed to the 4x plus 5. The biggest thing to remember with these is that we're distributing to the entire thing, not just the first terms and the last terms multiplied together, but all of the terms do get distributed together. 6x times 4x is 24x squared. 6x times 5 is 30x. Negative 7 times 4x is negative 28x. And negative 7 times 5 is negative 35. We will need to combine our like terms. 30x take away 28x. 30 take away 28 gives us a positive 2x, and then of course bring down the last term just as well as the first term. They just come down. Question number 2, we're going to find the sum. So for this one, we're going to just add the like term. There is no distributive property necessary because we're just finding the sum. You can rewrite these so that the like terms are lined up if that helps you. 6x plus 4x gives us 10x, not x squared. That only happens when we're multiplying, it becomes x squared. 6x plus 4x is 10x. Negative 7 plus 5 is negative 2. From Unit 3, we're going to find the difference. These were the complex numbers, a plus bi. So in order to find the difference, we're going to keep the first parentheses as it is, and then add the opposite. So keep, change, change. We're going to add, and then the opposite of each term, negative 4 and positive 3i. Now it's just an addition problem where we can combine like terms. Again, if you need to line it up to combine your like terms, or just take 12 and add negative 4, and then negative 5 and add 3. Example number 4, we're going to find the product. So let's set up our distributive property. We have 12 times the 4 minus 3i, and then negative 5i times the 4 minus 3i. So we'll distribute to each term. 12 times 4 gives us 48. 12 times negative 3, negative 36. Of course, don't forget your I. Negative 5 times 4. Again, remembering the I. And then being very careful on this last one. A negative times negative is positive. 5 times 3 is 15. And then I times I is I squared. Just like x times x is x squared, I times I is I squared. We also know that I squared equals negative 1. So that means we can replace this I squared with negative 1, and 15 times negative 1 is actually going to make this a minus 15. Instead of plus 15I squared, that I squared makes this become opposite. We're multiplying by a negative 1, so it becomes opposite. So now we can combine our like terms. 48 with a negative 15. 48 minus 15 is 33. And then the negative 36i minus 20i, negative 36 minus 20 is this negative 56i. Because when you're combining like terms, your answer is that like term. Let's look at the next one. we're asked to factor x squared plus 36. We look for a GCF first. X squared and 36 do not have anything in common. So now with two terms, we'll look to see if it's a difference of perfect square. And this one is not. It's the sum of perfect squares. So as soon as we see the plus sign with perfect square terms, we can say that this is not factorable. Because it is the sum of perfect squares, it is not factorable. Number 6, what are the zeros of the function? Well, in order to find the zeros of the function, you're going to just replace f of x with 0. So there's actually a couple different options on ways you could solve. My preference is factoring. If you can factor, I recommend factoring first. However, quadratic formula works on every problem. So I'm actually going to show quadratic formula in this problem, and I'll show factoring on another solution, or another problem to solve to find the solution. So quadratic formula, we need our a, b, and c. I like to start with the discriminant first, b squared minus 4ac. So b squared, being sure to square the negative, minus 4 times a times c. Work out the value of that discriminant. So b squared minus 4ac b squared minus 4 times a times c, being careful that we've typed in exactly what we want it to be. So we have 169 as our discriminant. So that should tell us we're going to get 2 real solutions, since that came out to be a positive number. So we'll actually need to find those now with our quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac, which we just did, so that's that 169, all over 2a. So we plug in for our denominator. So let's simplify this. We multiply to get positive 7 plus or minus the square root of 169 is 13. 2 times 1 is 2. Well, we've simplified as far as we can. Now we need to do the plus or minus. So 7 plus 13 we'll divide by 2, and 7 minus 13 we'll divide by 2. So 7 plus 13 gives us 20, but when we divide that by 2, we find our solution to be 10. And 7 minus 13 gives us a negative 6, but divide that by 2 and we get our solution to be negative 3. So our two solutions will be negative 3 and positive 10. Again, like I said at the beginning of this problem, you could have solved this by factoring. You would do product sum, so a times c. You'd find the product of negative 30. That gives you a sum of 7. So that would actually give us the factors, because our a is a 1, we could go straight to our factors of x minus 10 and x plus 3. So if you wanted to do it by factoring, do product sum. Once you get your factors, you would set each factor equal to 0. And hopefully already you're seeing once you add 10 and subtract 3, you get the same solution. So I'm actually going to show the full steps of factoring on this next one. We are going to solve another quadratic. In order to do so, we do need to start by getting it set equal to 0. So 0 equals x squared plus 5x minus 24. Of course, just like the previous one, you could use the quadratic formula, but I've already shown that on example 6, so I'm going to do solve by factoring on this one for this problem number 7. We have a trinomial, so we can do product sum. A times C. So we want the product of negative 24 that's going to add to give us a 5. Well, we know we need one positive and one negative. Because my sum is positive, we want to keep our big number positive. So start making your factor list. 1 and 24, 2 and 12, 3 and 8, 4 and 6. And notice I'm just taking 24 dividing by 3, 24 dividing by 4. You could try 24 divided by 5, it doesn't work. And then the next one you try is already in the list, so 6. So if you imagine leaving all these bigger numbers positive, we're going to tack on negatives to our smaller numbers. Because our sum is positive, that's how we knew to keep our big numbers positive. So we need a negative 3 and a positive 8. The order there does not matter. What does matter is the signs, positive 8 and negative 3. So let's replace that middle term. We're going to factor by grouping. So the first group has an x, and our leftovers are x plus 8. The second group has a negative 3, and our leftovers are also x plus 8. So our factors are x minus 3 and x plus 8. But we still need to set each of those factors equal to 0 in order to solve. So that's x minus 3 and x plus 8. So x minus 3 equals 0. When you add 3, we get a solution, x equals 3. And x plus 8 equals 0. Subtracting 8, we get the solution negative 8. So those solutions from least to greatest, negative 8, positive 3. Again, you could have found those by using the quadratic formula if you like that method better. Let's take a look at example number 8. We have a banquet hall for a party. The hall charges $15 a person with a required tip of $60 for the waiters. We have the total bill of $315 without tax, but she lost track of how many people attended. She writes and solves an equation where P represents the number of people who attended. So it shows the steps of setting that up and solving. It says which operation describes the missing work in step 2. So here in step 2, we have to determine how did we get from step 1 to step 3, what work would need to occur. Well, in order to go and solve this equation, you would need to do reverse order of operations. So think about reverse order of operations. We would first need to undo adding or subtracting. So that means we would need to subtract that 60, which is the correct answer for this equation. I'm going to go ahead and stop this video for these explanations and watch the next video to continue the explanations of the next set of questions.